Hi, this is a quick rundown of lecture 7, and just the first part when Alan took discrete variables to continuous variables. So hopefully this helps a little bit. This is what we've been looking at throughout the course so far. We've been looking at histograms that look like this. They are discrete variables because there is a variable here and here and here and here. This is the mode variable. It's also looks like the median is probably close to the mean, but all of these are discrete random variables. They might be in groups of 10 or 10 years. Now, at the lecture, what Alan did was instead of going 10 years, he went, well, let's make it 5 years. They're still discrete variables, but they're worth 5 years. Or maybe we can make them worth 1 year. Or maybe we can make them worth 1 month. Each column is only 1 month now. And as you see, as we make these intervals smaller and smaller, what we're actually doing is moving towards a discrete random variable. A continuous random variable. We're moved away from a discrete random variable. Now this looks like a continuous curve, and it's an approximation to a continuous curve. And we can say that this curve is symmetrical. It's a nice bell-shaped curve. It follows a Z distribution, perhaps, all these sort of things. But if this is a probability distribution or a probability function, then one of the most important things is that the area under this curve is equal to 1, because that's the sum of all the probabilities. The area under this curve is the sum of all the probabilities, and the sum of all the probabilities is 1. And with z-scores, that's exactly what the case is. They've been set, so the area under that curve is 1. And if you want to check that, the z-score for 0 is 0.5000. In other words, 50% of the scores are on this side, and 50% of the scores are on that side, on the other side. So together, that's 100%, which is just 1. So instead of looking at tables, we are going to start looking at integration. Now, Michael's put up some YouTube clips about integration, and Alan said he was going to keep it fairly simple. The other thing that you should realize about now that we've got this continuous variable is that all the rules still apply. All the rules about variance, all the rules about expected value, they still apply and still can be worked out. But that was the main part of that first part of the slide or of the lecture, going from discrete random variables where there is certain values of x to continuous random variables, and now we've got a curve. Thanks. Hope that cleared some things up. Thanks.